Hello everybody, my name is Stanislao Pastalano and today I will present you the Master's Degree Program in Autonomous Vehicle Engineering, MOVE. I will try, through simple questions and answers, to clarify as much as possible the aims, contents and details of the training that is planned for MOVE students. So, what is MOVE? In a sentence, MOVE is Federico's highly interdisciplinary master's degree program that prepares future engineers to work in the world of autonomous vehicles. Why choose MOVE? First of all, several companies involved in the production of land, naval and air transport vehicles are conducting significant projects with the aim of creating platforms with increasingly advanced autonomous features. Then, there are many contextual aspects that demonstrate the significance and the impact that autonomous vehicles will have for the future of our activities. With reference to terrestrial vehicles, in 10 years, fully autonomous vehicles will become standard, with an annual revenue stream of $7 trillion by 2050. In addition, the widespread adoption of autonomous driving technologies could lead to a 90% reduction in road accidents, with a 40% mileage coverage in Europe by 2030. The development of autonomous car technologies will lead to autonomy levels 4 and 5 by 2028, and the use of self-driving taxis, even if in a limited context, by 2025. Particularly, in the world of autonomous vehicles, connectivity will be a strategic element for the automotive market. In fact, it is estimated that this market will grow to generate around $1 trillion by the end of 2030. It will include the provision of infotainment services, advanced driver assistance systems, and all the technologies of autonomous cars and the Internet of Vehicles that enable the implementation of the proper functioning of driving services. There are several examples of companies that have developed significant projects such as Tesla, Uber, and Waymo. The latter in particular with the first fleet of self-driving taxis in service in Florida. Major companies, such as Hitachi, have already mapped out their development roadmap to lead the evolution of the so-called Smart or Advanced Driver Assistance Systems, ADAS, to ensure safety, comfort, sustainable performance, and accurate journey time estimation. In the aeronautical field, many projects have led to development of autonomous guided aircrafts for military and civil use. Similarly, in the naval field, there are evident cases of vehicle development for both surface and submarine navigation. In the mercantile field, then, navigation of autonomous vehicles is expected to be the future of transport companies, which will be able to use convoys of master-slave ships, exploiting the combination of artificial intelligence and teleoperation, or even small cargo ships for subcoastal navigation or unmanned ferries for canals or bays for the transport of passengers and cars. NATO and all major navies are carrying out unmanned marine vehicle development programs. There are several examples of application of naval vehicles for the inspection and maintenance of pipelines, drilling platforms, wind farms, and other offshore installations. In the world of road vehicles, several systems enabling significant degrees of autonomy are already a daily reality. Examples are collision avoidance technologies, lane keeping, and fully autonomous parking. So, if this is the current and future scenario, we might wonder what positions and skills are required in the world of autonomous vehicles. Companies today are looking for new skills. In particular, they are looking for engineers who know and combine traditional knowledge with the ability to design and manage the most efficient and competitive technological solutions. The professional features required concern experts capable of carrying out the detailed design in accordance with the regulation for the qualification and certification of autonomous vehicles. Furthermore, they must be able to participate in the development, production, and maintenance phases throughout the product's operating cycle. An example is the level of driver assistance, which, as it is well known, ranges from the stage of simple assistance during parking phases to fully autonomous driving. The knowledge of the autonomous vehicle engineer must be transversal, and it must include notions of mechanics, digital prototyping, and knowledge of propulsion systems for vehicles equipped with ADAS technologies. In addition, the autonomous vehicle engineer must have notions of electronics, machine learning, sensor data integration, and must also be an expert in driving, navigation, and control of autonomous vehicles, as well as in the integration of these vehicles within transport system management environments. The autonomous vehicle engineer must be able to integrate into collaborative development activities by having the potential to share and exchange functions. In the figure to the right, we see the classic V-cycle of complex product development according to the systems engineering approach. In such a development process, the autonomous vehicle engineer must act as a link between the nodes of the process itself and the vertical lines of investigation that the vehicle subsystems and technologies to be implemented require. The work environments in which these development activities take place are international, and therefore the autonomous vehicle engineer must be able to communicate in this context. Therefore, if we look at all these needs, we could explore the contents of the MOVE program together. The main contents of the MOVE program concern the design and management of land, air, and naval transport systems. Digital modeling and vehicle dynamics modeling for the development of the vehicle itself, the study of sensors and algorithms for driving, navigation, and control with high levels of autonomy, and finally, the integration of the autonomous vehicle in complex environments. Therefore, the professional features obtained through the MOVE program are a designer and a technology integrator for the development of autonomous vehicles, an expert in dynamics and digital modeling for the development of autonomous vehicle, an expert in systems for driving, navigation and control, and finally, an expert in autonomous vehicle integration in complex environments. Having outlined the main contents of the MOVE program, we can examine the more specific features of the program itself. The academic curriculum is firstly composed by three main subjects, which are made available to all students and thus representing a common cross-curricular training. The first subject concerns models and dynamics for the autonomous vehicle, and it is also complemented by laboratory activities. A second subject concerns digital modeling and design of the autonomous vehicle. And finally, a third and significant subject concerns the area of information and communication technologies, ICT, as it includes data integration, guidance and navigation, system control and robots, machine learning techniques, and image and video processing. Starting from the main subjects, the student's study plan unfolds, covering self-driving cars, unmanned aerial systems, and unmanned marine vehicles, respectively. The study plan is completed with an internship and a final master's thesis. The three main subjects highlighted in the slide by three colors are embodied in a series of courses in the first and in the second semester of the first year. They ensure the common contents of the program. In the first year, it is possible to observe the large number of courses in the ICT area. In the second year, a 12-credit course spread over 2 semesters prepare students for the demands of project development and collaborative teamwork. The 3 curricula that prepare for the different classes of autonomous vehicles are thus made available to students in the second year. There are 3 courses in the specialization curricula, and they cover a total of 24 credits, focusing on vehicle design and its integration into the system. A 9-credit free-choice course could be selected by the students as for all master's degree programs in Italy. Let us now turn to what are the admission requirements for the enrollment in the MOVE program. To enroll in MOVE program, candidates must possess a bachelor's degree in industrial engineering, Italian L9 class, or information engineering, Italian L8 class. Alternatively, they must possess a bachelor's degree in other science or technology degree classes in Italy or qualification obtained abroad, ensuring 36 credits in engineering and basic sciences disciplines. In both cases, a minimum of 12 credits in mechanical disciplines must be achieved during the bachelor degree course. Knowledge of English is required for entry, at least at a level comparable to B2 of the European Framework of Reference for Languages. We can go now into more details about the program contents. In particular, we can first detail the contents related to the first 2 subjects of common knowledge on vehicle dynamics and digital modeling and design. Firstly, several contents of vehicle dynamics are analyzed through mathematical models of the different subsystems. Then, starting from the vehicle models, students are taught to investigate using analysis and simulation environments to detail system behavior under different conditions, as well as to understand the integration of the vehicle subsystems. Several laboratory experiences enable MOVE students to gain competence in motion planning, vision systems, sensor integration, and driving control strategies. Through the digital modeling of interactive systems and interface course, MOVE students will gain in-depth knowledge of digital modeling techniques and interface development. An example of an interface between an autonomous mobile robot and a cobot developed by MOVE students is shown in the figures. Starting from the definition of functional requirements, students can analyze the behavior of systems and interfaces, as well as develop the digital prototype of the final solution. At the Ideas Laboratory, students will also be able to perform parametric CAD modeling of vehicles to test all the development and integration phases of subsystems, experimenting multiphasic modeling in MATLAB environment, as well as the physical prototyping of the developed devices. As part of the activities of the Laboratory of Autonomous Vehicle Design and Development, students go through all the steps of developing the design of a new autonomous vehicle concept by using MATLAB environment. With reference to the ICT area, there are numerous contents taught to all students. The Department of Electrical Engineering and Information Technologies, DIET, through the Distributed Automation Systems DAISY Lab, contribute with several contents for autonomous vehicles, such as the fundamental of control and system dynamics, information technologies for the development of intelligent and autonomous vehicles, the design of advanced driver assistance systems, ADAS, and algorithm using onboard sensors in the automotive and railway sectors. Finally, they also provide contents on cooperative networked control for connected self-driving cars or trains using wireless communication networks. In the area of technologies for object and people recognition, as well as in the interpretation of the contents of the environment surrounding the vehicle, students acquire basic skills for image and video processing, as well as skills on the model that need to be used to solve the main vision tasks for autonomous driving. Students are significantly involved in tasks related both to code programming and the use of large image and video datasets for training vision systems. A key element for autonomous driving is the use of sensors. It is therefore important to understand, on the one hand, how to measure and monitor the quantities of interest. On the other hand, it is necessary to understand the sources of uncertainty associated with the different measurements. Despite the use of redundant sensors integrations, the presence of non-ideal behavior in the sensors results in an uncertainty that must be controlled and improved appropriately. The video shows an application of sensor integration developed by MOVE students. The device allows the measurement of attitude, speed, and position to be used on different types of vehicles. Considering the specializing curriculum with reference to the area of self-driving cars, a series of contents can be highlighted. As regards the fundamentals of power and propulsion units for unmanned vehicles, a series of detailed contents are given on propulsion systems and possible architectures, such as series, parallel, and combined, by integrating conventional propulsion units with electric units. In particular, with reference to hybrid propulsion simulations, the basis for modeling and implementing control strategies as well as component dimensioning are provided. The micro-gas turbine test benches at the Department of Industrial Engineering are available for training and internship activities of students. A significant activity concerns the testing of the physics of the environment in which the autonomous vehicle operates, in order to investigate the integration between automatic logic and autonomous vehicles. Furthermore, MOVE students could use the equipment of an instrumented road, a smart road prototype located in Naples, close our university, in order to test data connections between vehicles. With reference to the unmanned aerial systems specialization curriculum, numerous contents are offered. Indeed, there are many contents and technologies for autonomous vehicles used in aerospace. For example, we can mention the autopilot, the fly-by-wire control, or even autonomous landing and collision avoidance technologies. In the unmanned aerial systems specialization curriculum, students can experiment with the development of collision avoidance systems. In addition, students are engaged in laboratory and external activities to develop and test technologies related to drones. Finally, regarding the unmanned marine vehicle curriculum, I would highlight the availability of a significant laboratory equipment in the Industrial Engineering department. The naval tank operating at the Department of Industrial Engineering allows students to carry out experiments on the proposal of new hulls. These experiments are accompanied by a significant CFD simulation activity that, together with structural design using carbon fibers, enables the development of new hull shapes for unmanned marine vehicles. Now, I would briefly summarize some of the laboratory activities carried out by MOVE students. This video shows the analysis of the interaction between an autonomous mobile robot and an operator. In particular, MOVE students performed real-time ergonomic analysis in order to assess the operator posture and the related load on the human spine. On the left side, it is possible to see the real-time evaluation of loads and the condition that such loads are lower than the limits imposed by international standards. As part of the course of image and video processing for autonomous driving, students developed a system based on neural networks for detecting pedestrians and vehicles with a very low margin of error. As part of the course on design of autonomous aircraft, students conducted activities on drones, applying the knowledge acquired on control and testing all the developed algorithms. Finally, it is possible to provide information on the internship and thesis steps, which have a duration of 12 credits and 15 credits, respectively. There are numerous internship opportunities to be carried out either at the Federico II University laboratories belonging to the San Giovanni University campus or at research institutions and laboratories in Europe. MOVE students participate in the Federico II University racing team called Unina Corse. The team's goal is to design and build a self-driving racing car to compete with other university teams from around the world. In particular, the work of the students in collaboration with MOVE lecturers at Daisy Lab Unina focuses on the entire control architecture of autonomous driving, including both the choice of different components and their integration. The great activity of the students and their passionate work resulted in a significant achievement. In fact, the team won the Italian competition and was ranked among the top racing teams in several competitions in Europe. Internship and thesis activities can be carried out by MOVE students at several companies that collaborate with the program. Companies operating in all sectors of autonomous vehicles collaborate in the training of students, showing a high level of interest in the professional features that the program prepares. For further information, I invite you to access the website move.dii.unina.it. There you will find information about the pre-enrollment procedure, scheduling of examination, detailed contents of each course. From the website you can also download the student guide with the collection of all relevant information about the program. You can also write us by using the mailbox move@unina.it. Finally, accessing the university website www.international.unina.it you could find all the most significant information, especially the ones regarding the procedures to be followed by candidates who do not belong to the European Union. Thank you so much for your attention. I hope to meet you as a future student of MOVE program.
Hello everyone. In this short presentation, I will illustrate the contents and the training program of the Master's Degree course in Industrial Bioengineering at the University of Naples, Federico II. I am Maurizio Ventre, course coordinator and professor of Industrial Bioengineering at the Department of Chemical, Materials and Industrial Production Engineering. In this presentation, I will try to answer the questions that are most frequently asked by students interested in enrolling in the course. What is industrial bioengineering? What are the main topics in the industrial bioengineering course? Where a graduate in industrial bioengineering can work? First of all, we need to clarify what industrial bioengineering is. Some doubts often arise regarding the differences between biomedical engineering and industrial bioengineering. Let's first say that there are no clear boundaries between the two disciplines. Both aim to solve problems related to health in its most general sense, and to improve human well-being and quality of life. But the tools that are used to achieve these goals show some differences. Industrial bioengineering is based on the principle, methods, tools, and technologies of industrial engineering, and in particular chemical, mechanical, and materials engineering. Bioengineering integrates these aspects with the knowledge of biology and medicine to develop devices for therapeutic diagnostic purposes. In more details, bioengineering deals with the study, design, manufacturing, and functional evaluation of instrumentation, medical implants, synthetic or natural biomaterials, tissue, systems, and organisms. A distinctive element of the industrial bioengineering concerns methodologies and tools that are based on the link between the structure and properties of biomaterials, biomechanical structure, and above all, biological artificial interfaces, which are of fundamental importance for the design and manufacture of medical devices. This is particularly evident in the case of implantable devices, where the interaction between biological entities and artificial systems ultimately determines the effectiveness of the treatment. This is probably the aspect that distinguishes industrial bioengineering from biomedical engineering, which is instead more focused on contents, methods, and technologies that belong to information engineering. In the industrial bioengineering course, the concepts of mechanics, thermodynamics, transport phenomena, science, and technology of biomaterials are provided and widely used. These concepts integrate with biological and medical knowledge to define the skill necessary for the design and fabrication and monitoring of materials and devices that interact directly with biological entities. These biological entities exist on various length scales, from nanometric to macroscopic. They can be biomolecules, cells, tissues, and organs. For each of these biological entities, there is a corresponding medical device capable of performing specific diagnostic and therapeutic functions. For example, biosensors are designed to interact directly with biomolecules and detect certain features, such as concentration or type of the moiety. Biomaterials of natural artificial origin are formulated to interact with cells and influence their behavior, such as addition or differentiation. Prosthetic systems and implants are manufactured to restore the functions of damaged or degenerated tissues or entire artificial organs that replace organs that no longer function. Here are some applications of the topics covered in the Industrial Bioengineering program. Nanomedicine is the technological and scientific frontier of diagnostic and therapy. It aims to develop and manufacture nanosized objects containing active ingredients or functional materials for therapeutic and diagnostic purposes. The precise formulation and functionalization of the nanometric vector allows the bioactive content to be targeted to specific anatomical districts. This improves the effectiveness of the treatment or the diagnostic power and at the same time reduces the side effects. There are various examples of nanotechnological products conventionally used today. Precision diagnostics, nanoparticles for the treatment of some types of tumors. Another example that you will certainly be aware of concerns mRNA vaccines that use nanocarriers that are appropriately designed to conjugate to specific cells and release the genetic information therein. After the anti-COVID vaccines, today mRNA technologies is under investigation to treat various diseases. In this area, industrial bioengineering has made a major contribution to the development, functionalization, and manufacturing of nanocarriers. Here we have organ-on-chips, which are miniaturized devices that contain human cells or tissues cultured in microchannels. Various types of fluid can be injected into these channels, allowing to study the response of cells and tissues in an extremely precise manner. The impact of this technology in the pharmaceutical industry is immense. Today, it is possible to study the effect of a new drug or substance directly on human tissues without having to use animal models. This entails several advantages. Predictive capabilities improve since the response of animals are often misleading due to their different physiology. The costs of experiment are reduced and the sacrifice of excessive number of animals is avoided. Prosthetic systems, and in particular endoprosthesis, are probably the application that best identify industrial bioengineering. In this context, the choice of biomaterials, the surface functionalization to improve the biocompatibility of the implant, the definition of the mechanical characteristics to create efficient, stable, and long-lasting prostheses are of crucial importance. In recent years, there have been enormous improvements in the field of manufacturing and functionalization technologies. In the development of new biomaterials with particular reference to the biodegradable ones and in design criteria that are increasingly bio-inspired. Finally, tissue engineering is a field at the intersection of engineering and medicine, which thanks to a skillful integration of biomaterials, cells, and in vitro cultural conditions, aims to regenerate entire tissues and organs in laboratory. On the one hand, this technology aims to resolve the shortage of organs and tissues for transplants, but it also aims to develop new processes to create human tissues analogs to be used as models for study of pathology, for drug screening, for the evaluation of the toxicity of compounds, things that are extremely difficult to study in humans or animals. Although these four examples may require different skills for their implementation, there is a clear and profound interaction with the biological environment. Industrial bioengineering is therefore intrinsically multi- and interdisciplinary. The development of devices that interact directly with biological entities requires knowledge and skills specific to various engineering, but also biological and medical fields. This map outlines how the various disciplinary areas are interlaced and their development contributes to the definition of educational path of the industrial bioengineering program. For the various courses, it is possible to identify cultural areas such as biology, bioengineering, chemical engineering, information engineering, and mechanical structural engineering. Each teaching is contaminated by other cultural domains, and together they all contribute to providing the knowledge and skills necessary for the design and creation of medical devices. In the first year, the industrial bioengineering program is structured in such a way as to provide with fundamental knowledge of the biological language, the knowledge on molecular, physical, and mechanical signals that are necessary to interact with the biological world. Also, The tools to analyze and predict the response to certain signals are provided. In the second year, there is a greater attention to the implementation and application aspects of the industrial bioengineering. The second year courses illustrate the design criteria and technologies for the manufacture of devices for diagnostics and therapy. The training program is completed by eligible subjects, the internship and thesis project. In more details, the course of biochemistry and cell and molecular biology illustrate the variety of biomolecules and signals that are the foundation of cellular life, providing knowledge on metabolism, biosynthetic activities, and cellular functions. System analysis and system and synthetic biology courses aim to provide students with knowledge to model intercellular biochemical reaction in order to predict cellular behavior under certain stimuli. Biomechanics and mechanics of tissue and growth aim to analyze and model the biomechanical behavior of living structure on various dimensional scales and also in dynamic condition. Those that concern growth and development in both physiological and pathological conditions. Thermodynamics in transport phenomena in living systems aims to apply the fundamental concepts of thermodynamics and transport phenomena in the bioengineering field. In summary, these courses deal with chemical physical balances and the transport of momentum and matter in complex biological systems. Students will therefore be able to model and predict the behavior of biological tissues, medical devices, or combination thereof under certain experimental conditions, physiological or pathological environments. Microfluidic for Lab-on-Chip module aims to unravel microfluidic flows, provide criteria for the design, modeling, and manufacturing of lab-on-chip, miniaturized devices that process molecules, materials, even cells for analytical and diagnostic purposes. In the course of diagnostic devices and drug delivery, the design criteria and the manufacturing technology of devices for specific application in the diagnostic and therapeutic field are provided. Modeling techniques for bioactive agent release and efficacy in the biological environment are also illustrated here. In biomaterials and tissue engineering, an examination of biomaterials with a particular focus on those of interest in regenerative medicine, on manufacturing and functionalization technologies performed. The techniques for the in vitro generation of tissue by hybrids, the modeling and optimization of culture condition and investigation methodology used to monitor the growth processes are then illustrated. Finally, a series of application of tissue engineering products in the field of organ-on-chip technologies and therapeutics are presented. The biomedical imaging and computer interface for biological systems courses aim to provide students with the essential concept inherent to the recording, processing, and analysis of biomedical signals. In the first case, the focus is on medical images concerning cells, tissues, and organs, while in the second, the attention is placed on sensor biological environment interfaces. Finally, the Robotics for Bioengineering course provides the concepts for modeling and control of robotic systems made up of kinematic chains, as well as design principles of robotic system for medical application, for example, in surgery and rehabilitation. Among the eligible subjects, we encourage students to study artificial organs and prostheses or design of biomedic devices. The first course illustrates the functional characteristics and biocompatibility of endoprosthesis and other temporary medical devices. It provides students with engineering tools for their design and manufacturing, and finally illustrates the operating principle of some artificial organs. Design of biomedic devices teaches how to design and develop devices for therapy and diagnostics. Mainly based on microfluidics, the course integrates knowledge on machine learning and the analysis of diagnostic data. The training course is completed by an internship, which can be carried out in the laboratories that participate to the educational program, or it is possible to organize the activities at companies or at the other institution affiliated with the University of Naples. The thesis project worth 12 credits concern experimental activities or the drafting of an extended review text. And this can be carried out either in the internal laboratories of the University of Naples or as part of agreements with other universities or within Erasmus programs. From this year, the Industrial Bioengineering program is one of the proponents of the minor in applied machine learning. This minor is an interdisciplinary thematic pathway that provides knowledge of the typical tools of artificial intelligence applied to the field of chemistry and process and product engineering. The course consists of 27 additional training credits, 6 of which are reserved for extracurricular activities. Industrial bioengineering students can participate in the program and in principle can use eligible activities to complete part of the thematic pathway. Those interested in this minor can consult the link of the minor in applied machine learning, in which he or she can find all other useful information. Students of the Industrial Bioengineering program can participate in Erasmus programs such as Erasmus Plus and Erasmus Plus Traineeship. For the Erasmus Plus Mobility program, 8 agreements are currently active with universities in Belgium, France, Greece, Spain, and Hungary. The Erasmus Plus Traineeship program does not foresee specific destinations. Students can agree with the research laboratory of European or non-European institutions or companies to carry out internship or thesis projects. The Industrial Bioengineering program includes a number of practical activities within various courses. The laboratories where these activities are carried out are those of the Department of Chemical, Materials and Industrial Production Engineering, among which we mention Biomaterials and Tissue Engineering, the Cell and Molecular Engineering Lab, and the Optical and Confocal Microscopy Lab. There are other laboratories of the Interdisciplinary Research Center on Biomaterials, where the activities are carried out in the 3D Printing Lab and in Chemical Synthesis Lab. The students can also participate in practical activities conducted at the laboratories of the Center for Advanced Biomaterials for Healthcare of the Italian Institute of Technology, which supplies the ultrastructural characterization facility, organotypic culture laboratory, and the microfabrication facility. Other labs are at the Change and at the TGEM, in which activities are carried out within the courses of biochemistry and cell and molecular biology. International students graduated in engineering disciplines, preferably with a BSc or BE in biomedical engineering, chemical engineering, or materials engineering, can enroll in the master degree course Industrial Bioengineering, provided that they have a sound knowledge in mechanics, thermodynamics, transport phenomena, materials, and or biomaterials science and technology. They can send their transcript of records to the coordination committee for a pre-evaluation and possibly an approval. A CGPA of at least 8/10 is required, along with a certification of knowledge of English language at a level equal or higher than B2. Let's now analyze what the possible job opportunities for industrial bioengineering graduates are. This analysis is based on data of the students who graduated in industrial bioengineering in the last 5 years. Our graduates work mainly in industries, in the research and development sectors, and for companies that offer consultancy services. In the industrial field, industrial bioengineering graduates are employed in the sectors related to implantable medical devices and substance-based devices. a good percentage of graduates are also employed in the pharmaceutical sector. To a lesser extent, there are graduates employed in chemical companies and in particular in those companies that produce cosmetics and detergents. Other graduates work in the biotechnology sector, dealing with the implementation of bioprocesses and other in precision mechanics. A good portion of graduates are engaged in research, both in the research and development departments of pharmaceutical and biomedical companies, and in public and private research institutions. Companies offering consultancy services are an important point of attraction for our graduates who deal with consultancy in the fields of software for biomedical equipment, biomedical data management, certification and classification of biomedical devices, and project management. Before concluding this presentation, I would like to contextualize the biomedical sector in the Italian and the European industrial scenario. The statistic you see refer to the year 2022, therefore still influenced by the pandemic events. However, important signs of recovery are evident. The Italian market is growing by approximately 6.9%, as is the production of 9.5%, and the export of biomedical products also is rising. To date, the biomedical sector employs more than 117,000 people in over 4,600 companies. The core business of this company is very broad and involves all biomedical and bioengineering fields. The medical device sector is certainly the most present, followed by biomedical instrumentation and substance-based devices. The training of graduates in industrial bioengineering is particularly akin to these three sectors, and in these sectors, graduates can find a valid employment. Other sectors of particular interest for our graduates are those of in vitro diagnostic, dental implants, and optics. Throughout Europe, there are 850,000 employees in the biomedical sector, and Italy represents approximately 14% of this workforce. It is a very advanced sector from a scientific and technological standpoint. And this is demonstrated by the fact that 50% of employees are graduated and 7.8% are employed in research and innovation activities. I would like to conclude this presentation by reminding you of our contacts. You can refer to the website of the Department of Chemical, Materials and Industrial Production Engineering, and under the section Education, you may find the main website of the master's degree in Industrial Bioengineering. For direct contacts, I invite you to follow us on social media, Facebook and Instagram, where you can interact with us for any information or curiosity, or just follow our update. I also invite you to subscribe to our YouTube channel. The course email is bioengineering@unina.it, where you can send us your requests for information of
I am Giovanni Andiruperto, coordinator of the Master's Degree course in Chemical Engineering. With the help of 3 other professors, I will try to introduce you to our educational path. The presentation will be multi-voiced as detailed in the outline. I will start with a quick introduction, and then my colleagues Danilo Russo, Massimiliano Villone, and Francesco Di Natale will speak about the 3 different curricula. I will conclude with some information on the other opportunities to customize your educational path through optional exams, through the so-called minors, and some extra-many activities, typically through the Erasmus project. But why 3 different curricula? The reason is that the job of chemical engineers has changed considerably, and now chemical engineers are in many different areas. While in the past they design, build and manage chemical processes and plants for the transformation of raw materials, aiming at the production of a variety of commodities, today chemical engineers can be found nearly everywhere. A chemical engineer is considered a universal as well as a multi-scale engineer. From the molecular scale, necessary to understand the link between structure and macroscopic properties, he moves to the micron scale, typical of microfluidics, useful, for example, to design biomedical devices. And then he deals with the formulation and large-scale production of a huge variety of goods. He then deals with energy conversion from traditional and renewable sources. He designs and manages plants and is also an expert in environmental challenges, always with a constant attention to safety and sustainability issues. To properly address current and future challenges, students can choose between the process engineering curriculum, offered in Italian, and two other curricula entirely taught in English, namely product engineering and sustainable engineering. The three curricula obviously have many common features, necessary to consolidate and enrich the knowledge and the skills acquired at the bachelor level. They are thermodynamics, transport phenomena, unit operations, reactors, and so on. Details on the training path are shown in this slide that highlights the differences between the three curricula. They obviously are significant and correspond to approximately 30% of the credits. Regardless of the choice, at the end of the course, students will be issued the master's degree in chemical engineering. I will now give the floor to my three colleagues, Danilo Russo, Massimiliano Villone, and Francesco Di Natale, who will give you more information on the three curricula.
Hello everyone, my name is Danilo Russo and I'm an assistant professor of chemical engineering here at the University of Naples Federico II. In this short video, I'll give you an overview of the specification of the master's curriculum in process engineering. Now, the master's course has two main objectives. The first one is for sure to consolidate and enhance the fundamental knowledge that is already partially acquired during the bachelor's degree course program. But on the other hand, we also want to train professionals that can enter the work environment with professional behavior, ethics, and deontology. Now, within this framework, the different available curricula are opportunities to build specific know-how as a set of theoretical and practical skills that will characterize your way of being a chemical engineer in your professional future. In this way, we can conceptualize the different curricula as particular keys to understanding the common challenges that chemical engineers are addressing now and in the near future. And we can look at them, at the different curricula, as tinted glasses, giving specific perspectives towards different aspects of the professional reality of chemical engineering. So, what is the essence of process engineering? Well, in my opinion, a process engineer can, more so than others, have an overarching perspective of all the unit operations for matter and energy transformation that make up a chemical process as a whole, from raw materials to intermediates and semi-finished products up to the final products of interest, with a particular attention to waste management processes for circularity and sustainability. Process engineers rapidly realized that every chemical process can be seen as a set of unit operations and fundamental process blocks that come together like jigsaw pieces in order to achieve a desired product or objective. Now, process engineers must be able to design and manage the complexity coming from the interaction of so many different units, always keeping in mind the cost, safety, and sustainability effectiveness criteria of chemical processes. So to sum up, a process engineer must know how to design and manage unit operations, but also their subsequent interactions. They have to be able to carry out software simulations, also under dynamic conditions, in order to optimize and control a process and avoid, for example, the occurrence of adverse or accidental scenarios, while also knowing how to assess and minimize risks to health, safety, infrastructure, and the environment. Now, in order to achieve these objectives, we propose an interdisciplinary curriculum that sees core courses, like the ones you see here in blue in this table, to consolidate and improve fundamentals of thermodynamics, transport phenomena, safety, control, chemical reactors, and structure engineering, alongside with specialized courses, the ones in red in this table, that are also characterized by the possibility to work in small groups on specific projects, which are assigned by the lecturers to put the acquired theoretical knowledge into practice. The skills that are provided by these courses cross many sectors and will produce process engineers that will be able to work in a variety of work environments with high flexibility. Now, together with the economics and business organization course, the engineering courses provided are the one of unit operations in process industry. In this course, students will dissect the fundamental units I've shown you before that make up a chemical process, and will learn how to design and operate them from a microscopic scale to a full plant scale, including through the adoption of commercial softwares. Process engineers will soon realize that almost every energy and matter transformation process requires the adoption of catalytic systems, from the most traditional to the most modern ones. And in the industrial catalysis course, students will acquire the fundamental knowledge to understand and manage catalytic systems and their applications, encompassing long-standing traditional production processes to innovative biomass conversion processes, for example, electrocatalytic processes in electrolyzers and fuel cells, and applications for the abatement of common pollutants in environmental catalysis. In the course of nonlinear dynamics of chemical processes, students will understand that individual unit operations, or a system of many unit operations, can be executed under a variety of different conditions. And the change from one set of operating conditions to another is characterized by complex nonlinear dynamics. And the student will learn how to model and manage these dynamics in order to maximize yield and productivity, for example, or minimize costs of our processes and avoid the runaway of systems towards unstable conditions that can lead to accidental hazardous scenarios. Such hazardous scenarios will be learned in the course Risk Analysis of Chemical Processes. Now, every chemical process, like the ones you see in this slide, for example, occur in the presence of a large number of toxic, flammable, and explosive materials that can lead to accidents. And in this course, students will be grouped and asked to work in team to carry out a quantitative risk assessment of a chemical process, learning how to predict possible scenarios, calculate their frequency of occurrence, and model their consequences in order to prevent their occurrence or mitigate their effects. Let me conclude with an example of a process engineer's perspective on an innovative and less traditional transformation process, such as the production of green hydrogen using renewable energy through water electrolysis in order to produce hydrogen that can be employed in the chemical industry, for example, or for mobile applications, such as in the transport sector. Now, while the more traditional and expected know-how is the design and management of the chemical processes in which hydrogen is utilized, the overall perspective of a process engineer will allow them to be able to identify renewable energy systems and enhance their energetic efficiency, for example, to identify systems requiring catalytic or electrocatalytic systems for the transformation of, for example, electrical energy into chemical energy or vice versa. Identify the critical points to prevent accidents and their consequences, like in the case of a compressed hydrogen refueling station, or even adopt nonlinear dynamics modeling to understand less traditional problems, such as the dynamic response of a hydrogen vehicle fed with hydrogen stored at high pressure. Now, our graduate students are rapidly employed in many different sectors, thanks also to their master's projects, which are of great industrial interest. One example of industrial application of acquired know-how can be seen here in the master's project of Alessandro Sferragatta, who designed a full process to energetically sustain a monumental site, like the Caserta Royal Palace, starting from biomass waste. Alessandra now works in FATA as a purchase assistant. Or we can see the example of Elena Capasso, who has continued as a researcher here in our department, who investigated and patented, while in the department, a novel process for the production of hydrogen from bioalcohols with the possibility to fix carbon as a high added value polymeric product, minimizing the CO2 emissions. Or finally, Andrea Di Domenico, now loss prevention engineer at Saipem, who modeled during his master's project the release and dispersion of methane hydrogen mixtures from gas pipelines during natural catastrophes. Now, with these examples, I'll finish my presentation. But before leaving you, I want to remind you to make your choice based on your personal interests, inclinations, and passions, because in every case, you will become a chemical engineer able to address the many challenges of this profession, but with a personalized set of skills and point of view. Although I should say that this will be an initially personalized point of view, since our profession is a very dynamic one that has to adapt to the ever-changing challenges of the world's energy and production scenarios. And in fact, your education will actually last for the rest of your professional life. And with this, I kindly thank you for your attention. Feel free to contact me and my colleagues at the email addresses which are provided in this slide for further information, and I wish you luck with your decision.
Hi, I'm Massimiliano Villone, also a teacher of the Chemical Engineering Master's degree course at the University of Naples, Federico II. I present to you the Product Engineering curriculum, whose educational activities take place in English. To briefly introduce the concept of formulated product engineering, I want to start with an example. Do you know what you are seeing in this video? This is a 3D printing process of a starch-based mixture formulated to reproduce the mechanical properties of meat. Over the last decade, chemical engineering is undergoing a paradigm shift. In particular, the attention of this discipline is progressively shifting from the industrial production of simple chemical compounds, let us think, for example, to ammonia, nitric acid, sulfuric acid, to the design and production of formulated products. To give an idea, now, more than 50% of the reference markets for chemical engineering are represented by formulated products. The formulated products are designed and manufactured in an innovative way to meet the needs of contemporary society in terms of sustainability, functionality, and attractiveness in the most disparate fields, from the food to the pharmaceutical industry, from the detergent to the fuel sector, and many others. If you think about it, the example I showed before is representative of this new paradigm, since it brings together an innovative process, 3D printing, sustainable raw materials, cornstarch, and the production area characteristic of the formulated product engineering, namely food. The formulated products are multi-phase systems composed of different chemical species and characterized by microstructure, which means a morphology on a sub-millimeter dimensional scale. The microstructure depends, in turn, on both the chemical formulation and the process conditions. It could be said that whereas the classical chemical engineer is used to operating on the macro and mega scales, namely those characteristic of unit operations and plants, the product engineer enriches his cultural baggage with the skills necessary to operate on the micro scale, corresponding to the dimensions of bubbles, drops, and particles that characterize the structure of the formulated products, and the nanoscale, corresponding to the characteristic lengths of molecular interaction which determine the behavior of the matter on larger scales. Beyond the educational activities that are common to the three curricula of the master's degree in chemical engineering, the knowledge and skills that specifically characterize a product engineer are provided within the courses listed in this table, that is, applied physical chemistry, rheology, unit operations for product engineering, modeling and numerical simulation of chemical processes, and soft matter engineering. In the course of applied physical chemistry, located in the first semester of the first year, the concept of soft matter, that is, a state of the matter characterized by intermediate properties between those of the liquids and those of elastic solids, is introduced for the first time, and its physics is studied. Particular attention is dedicated to the description of the behavior of matter at the molecular level and the implication this has with respect to the microscopic properties of the matter itself, both at equilibrium and in dynamic conditions. Let us think, for example, to viscosity or diffusivity. It can be said, therefore, that this course establishes the link between the behavior of matter on a nanomicroscopic scale and that on the macroscopic scale. In this framework, elements of chemical kinetics are also introduced. The areas of application that are most specifically explored in the course are those of polymeric solutions and melts, physical and chemical gels, and liquid crystals. The rheology course is located in the second semester of the first year. Rheology is the discipline that studies the deformation and flow of complex fluids, a category which includes all systems of interest in the engineering of formulated products. The behavior of complex fluids is very varied and differs profoundly from that of Newtonian fluids, such as water, oils, and gases. For this reason, those fluids are referred to as non-Newtonian. One of the salient aspects of the course is the measurement of the rheological properties of non-Newtonian fluids, namely rheometry. With this in mind, the students of the course will learn to carry out and interpret rheometric measurements through laboratory activities. During the unit operations for product engineering course, located in the first semester of the second year, the processes of greatest interest in the engineering of formulated products are introduced, and students will learn to design the equipment that allows to realize them on an industrial level. The operations and equipment characteristics of the world of formulated products are numerous and are often different from those of classical chemical engineering. For example, industries that process perishable products such as food or pharmaceuticals require attention to mixing and storage issues. Within the course, emphasis is also placed on the operations involving heat transport, such as cooling, freezing, thawing, pasteurization, sterilization, and evaporation, and simultaneous transport of heat and mass, such as drying, freeze-drying, and extraction. The soft matter engineering course, located in the first semester of the second year, deals with examining in depth the problem related to the behavior of soft matter, of which I provided a quick definition before. In this area, the interaction between microstructure and properties of multi-phase systems like suspensions, emulsions, and foams are studied with particular attention, showing how to engineer the microstructure to obtain stable systems characterized by the desired mechanical properties. Furthermore, innovative production techniques are introduced within this course, such as additive manufacturing, which allow products to be created in a more sustainable way, significantly reducing processing waste. Finally, the students of the course will learn to set up and carry out processes for the manipulation of systems of interest in the field of soft matter engineering, such as extrusion or 3D printing, through dedicated laboratory activities. Last but not least, the Modeling and Numerical Simulation of Chemical Processes course, also located in the first semester of the second year, introduces a powerful tool widely used in industrial engineering, and therefore in the engineering of formulated products, the Eve Computational Fluid Dynamics, CFD. This term refers to the techniques that enable to simulate flows even geometrically complex or fluids even rheologically complex through the writing and solution of mathematical models that appropriately describe them. This allows to study the behavior of the system of interest when many operating parameters such as flow rate, pressures, concentration, temperature vary, which would be very difficult and expensive, if not impossible, at an experimental level. To do this easily, commercial software with a graphical interface will be introduced, which students will use extensively within the course. As said, the study plan for the master's degree in chemical engineering includes 18 credits connected to activities to be freely selected. Without prejudice to total freedom of choice, including training activities far from the field of formulated product engineering, the elective courses listed in this table allow those who wish to delve further into this world for in-depth analysis of various aspects related to the topics of the curriculum, such as advanced techniques for simulating the behaviors of matter, molecular thermodynamics, food engineering, formulation chemistry, interface engineering, and machine learning techniques applied to product and process engineering. With this, I greet you and thank you. Bye!
Good morning, everyone. I'm Francesco Di Natale, Professor of Chemical Plants at the University of Naples Federico II, and in the next minutes I will briefly introduce you our curriculum in sustainable engineering that lies within the framework of our master course in chemical engineering. First, let me start with a premise. Sustainable development is a philosophical and political approach to social, economical, and environmental planning that attempts to balance the social and economic needs of present and future human generations with the imperative of preserving the natural environment. The paradigm of sustainable development is to meet the needs of the present generations without compromising the ability of future generations to meet their own needs. This requires a relevant shift in the design and operation of existing production process. In this scenario, chemical engineering plays a significant role. Indeed, these disciplines aims to generate and to study large-scale chemical processes and to design and manage technologies and processes that makes the latest findings in chemistry and modern engineering available to society. Sustainable chemical engineering is a branch of chemical engineering that aims to develop processes, plants, products, and decision-making tools which are effective, safe, produced with a low environmental impact and a high level of energy source integration, as well as having a very good life cycle profile. In a few words, safe and sustainable by design. The contribution of sustainable chemical engineering are recognizable in the development of process and technologies for green chemistry, energy transition, and circular economy. Additionally, it plays a fundamental role in the production of sustainable materials and minimizing the environmental impacts of existing plants and processes. Finally, sustainable chemical engineering actively contributes to the development of industrial ecologies and to methodologies for the strategical analysis of the economical and social impacts of production processes. The importance of sustainable chemical engineering is evident in the professional careers, where alongside traditional careers for chemical engineers, new green careers closely linked to sustainability are emerging. I'm thinking about energy, mobility and sustainability managers, sustainable materials experts, and sustainable finance experts. To achieve its goals, sustainable chemical engineering has developed various strategies and methodological approaches involving process intensification, integration with renewable energy sources, development of bioprocesses, methods and processes for waste recycling, as well as life cycle assessment tools. As a consequence, it appears that to train a chemical engineer in sustainability, it is necessary to develop a dedicated educational program set within the framework of traditional chemical engineering. To this end, the Sustainable Chemical Engineering educational program aims to integrate the basic knowledge of chemical engineers with the new knowledge and methodological approaches, including, in addition to those previously mentioned, the concept of industrial ecology, circular economy, and regenerative chemistry, new catalysis processes, and digitalization methods. These methodologies, along with numerous application examples, are the backbone of the Sustainable Chemical Engineering course at the University of Naples Federico II. Many of the methodological contents are presented in the core fundamental exams, among which students will easily recognize those dedicated to the bioprocesses and bioreactors, design of sustainable equipment and processes, industrial chemistry for renewable resources, and environmental engineering. However, several application examples are presented in the wide range of elective exams that can be closely linked to this curriculum and in the minor in green technologies of our university. The curriculum is completed by thesis work, where students can take on numerous real-world problems, from bioprocess development to CO2 capture, from precious metals recovery to machine learning applications, from photocatalysis to energy integration, and much more. In summary, the Sustainable Chemical Engineering curriculum is a modern and dynamic educational program that aims to combine strong bases in chemical engineering with the knowledge and skills necessary for the sustainable development of production and energy chains. The curriculum aims to train chemical engineers capable of designing and manufacture safe and sustainable processes and products, engineers educated in using a systemic vision of problems, capable of supporting the analysis of the social and economical effect of production process, and able to contribute to the development of increasingly accurate and effective strategic decision-making tools. With this, I think I can conclude. Thank you very much for your attention, and please contact us if you need any additional information.
The educational path can be further tailored and enriched by taking advantage of the optional exams, as well as by attending a short, highly interdisciplinary path called minor. This table collects the suggested optional exams. They are organized into 4 groups. The first is of transversal wide interest. The other 3 are more focused: energy, environment, and sustainability. Then we have formulation engineering, and finally a safety engineering group. As regards minors, these are thematic courses with a strong transversal character, which among other things allow students to obtain an additional certification known as Open Badge. Our minors have a size of approximately 30 credits, in fact corresponding to 1 semester, but approximately 10 credits are extracurricular, i.e. they are on top of the standard 120 credits required to obtain the master's degree. This small additional effort is, however, sort of compensated by the Open Badge. The minors we offer are in green technology, applied machine learning, and pharmaceutical engineering. The keywords of the minor in green technology are circular economy and energy transition. It will also be possible to acquire skills in the field of thermomechanical and electrical technologies. The minor in applied machine learning allows students to learn the use of artificial intelligence tools with techniques such as machine learning or deep learning, thus making it possible to develop predictive statistical modeling starting from large databases with the aim of reducing process development times and costs, hence improving productivity, efficiency, as well as quality. The third minor is pharmaceutical engineering, a new branch of knowledge that combines typical engineering skills with those more closely related to the chemical pharmaceutical world. The aim is integrating knowledge on the discovery, formulation, and production of drugs with industrial reality in which these processes are carried out. Finally, I would like to point out a further opportunity, that of obtaining a double master's degree, chemical engineering plus mathematical engineering, with an obviously higher cost than the minors, around 60 ECTS, i.e. roughly 1 extra year. I would like to conclude by recalling that the educational path also includes activities outside our university through the well-known Erasmus programs. I focus here on the very recent innovation of the so-called Italian Erasmus, which will allow students to spend a period ranging between 3 and 6 months in other Italian university for exams or for thesis activity. In 2024-2025, in the next year, the possible destinations will be Padua, Pisa, Cagliari, and Catania. It is also possible to carry out internships in companies or research centers affiliated with the Federico II University. Further information is available in the link mentioned here in the slide. Some of the typical destinations within the Erasmus project or for internships are highlighted in this slide. At the end of the training course, the employment level is very high. After 1 year, approximately 90% of the master graduates already have a job. I wish to highlight the perfect gender balance of our master's degree, with the presence of women that is often higher than that of men, an unusual aspect in engineering courses. For further information, please refer to the course website, where you will also find the contacts of teachers, of all teachers, and of the student representatives. The department and university orientation pages, also reported here, can certainly be useful.
Hello, everybody. My name is Cino Bifulco. I am the director of the study program in Transportation, Engineering and Mobility. This master degree is framed into the area of the civil engineering, but as we will see in the next minutes, it is characterized by a great level of multidisciplinarity. The master's degree is related, of course, to transportation engineering and is intended to give to the students all the theoretical and practical tools to deal with the sector of mobility, which is a very, very active sector, increasing in importance and increasing in technological aspects. Before moving on with the presentation of the master degree in Transportation, Engineering and Mobility, let me show you some figures that relates to the economic footprint of the sector in Europe and in Italy. For instance, taking into account that transportation in Europe means that we deal with millions of companies that work in this field. And this means also millions of employees. The added value to the European gross domestic product is about 15%, which is a terrific amount that has no comparison with other sectors. The turnover is of 3,000 of billions per year, of course. Modes that compose the transportation sectors are road, railway, air, waterways, intended in vehicles, infrastructure, and services. In this set of modes, 80% of passengers travel by road, which is so the most important mode in transportation, and 50% of freight is moved by roads. This is an indicator of the relevance of the road sector, but also an indicator of some tricky aspects because road transportation for both passenger and freight is not the more sustainable way to move and transport. For what relates to the transportation infrastructures, so infrastructure are one of the aspects of a transportation system, is the more physical, let me say, aspects. For what relates transportation infrastructure in Italy, takes into account that 91% of the transportation infrastructure in Italy are roads, and while others 6.6% are railway, tramways, metros, and funiculars, and the rest, which is quite negligible, of the transportation infrastructures are related to the air or to the waterways transportations. So the total length of roads is many thousands of kilometers, and the total length of railways is some tens of thousands of kilometers. Ports in Italy are about 300, and airports are in Italy are 44 public airports, of course. Transportation systems are not only transportation infrastructure. A great role is played by transportation services, maybe a role greater than one's of transportation infrastructures. So, moving passengers in Italy, all those figures are related to Italy. Moving passengers in the domestic trips in Italy, so the ones that remain within the Italian territory, means that a really great amount of passenger per kilometers is produced in terms of transportation services. Take into account that if one bus move one person for 1 kilometer, this means one passenger per kilometer. So what is moved on road by buses and autos, of course, also private transportations, and is a really huge amount of passenger per kilometers. This is equivalent to more than 22 millions of trips around the world. It's something like just for road is something like one inhabitant on two in Italy each year takes one trip around the world moving on the road network. If you add to the road, the rail, the air, and the waterways transportation in terms of passenger per kilometers, you reach 24 million of trips around the world, the equivalent of 24 millions of trips around the world. It is not different, the importance, the relevance of the sector if you look from the freight transport point of view. Once again, referring to Italy and only to domestic trips, the amount of tons per kilometers moved on the road system is 104 billions of tons per kilometers. Take into account that if one truck move 1 ton for 1 kilometer, this is 1 ton per kilometers. Okay, so Roads takes the great part of the transportation of freights with a modal share that is in favor of roads for 53%. So 50% of the freights are moved by roads, but while waterways have an amount of transportation over 30%, rail is 16, air is just 100, is just 1%, 1%. Take into account that we are speaking about domestic transportation freight. So if you want to have an idea of what this amount of freight means, of moving freight means, this is equivalent to 27 million of male African elephants that each year are moved from Bolzano in the north of Italy to Reggio Calabria in the south of Italy. Okay, this is a terrific amount of things that are moved. And this is thanks to transportation services. So, given the previous figures that relates to the relevance of the transportation sector in Europe and in Italy, and so you can imagine what happens if you look on a global, on a worldwide scale. Let's go understand what are some topics in which transportation and mobility engineers are involved in. This range from driving behavior, road safety, so understanding how drivers behave when they drive their car. This is, yes, of course, this relates to safety aspects in traffic, but it also relates to the efficiency of traffic and on the flowing on roads. Another topic relates to design and management of transportation services. We saw which is the relevance of the transportation service sector. So this means that to design how fleets of buses should behave in order to give services to people that have to move, or fleets of cargoes of for transportation of freights on other services. A relevant sector that is emerging in the last year is the one of the new concept of mobility as a service, MaaS, mobility as a service. That means that intermodality, using each mode of transport in its better field of use, is the way in which we can improve sustainability. And this can happen if some mass mobility as a service operators are put in a layer between the customer that are we as we move as travelers and who offer and manage transportation services, so that each of our as customer can have his customized way to move in the best manner from its origin to its destination, employing at the best the whole offer of transportation with a great multimodal behavior. Transportation planning is a traditional, but let me say an evergreen field of experience for transportation engineers, and planning transportation networks or the transportation services means to evaluate how different alternatives to give services or to build infrastructures can have different aspects, different impacts also from the economic aspects, and to choose which is the best option. And the world is changing, is rapidly and revolutionary changing, and so we now are facing some very new challenges that are related to the CCAMs, the cooperative, connected, and automated mobility. Means that cars and passengers and pedestrians and bikers and waters are connected each to the other and are connected to the infrastructure, for instance, to the roads, and that this connection in terms of communications allows for a cooperative behavior. So no one behavior no more on an individual basis, but we can go in a cooperation each to the other thanks to the information. These are some effects. One of the terrific effects could be on the capacity of roads to increase their throughput, for instance. And another aspect that is very relevant is that this helps pave the way for the automation of the mobility.
Sono Ennio Cascetta, presidente del Cluster Nazionale Trasporti, che è un'associazione di imprese e centri di ricerca in tutti i settori dei trasporti terrestri. Oltre 30 grandi aziende, grandi e piccole aziende partecipano al cluster, da Ferrovie dello Stato, Stellantis, Itaci, Fincantieri e tante altre aziende fino a delle piccole start-up, con oltre 30 centri di ricerca che fanno capo alle principali università italiane. Un totale di 33 miliardi di euro di fatturato e migliaia di persone lavorano in queste aziende. E questo gruppo, questa associazione, il Cluster Nazionale Trasporti, è profondamente convinto che nel nostro Paese, come in tutto il mondo, stiamo attraversando una fase veramente rivoluzionaria di cambiamenti e di innovazioni tecnologiche e organizzative che riguardano i sistemi di trasporto. I veicoli a guida autonoma, la decarbonizzazione dei trasporti, la creazione di veri e propri nuovi servizi di mobilità per le persone e per le merci stanno cambiando e cambieranno in modo radicale il sistema dei trasporti, della logistica e della mobilità nei prossimi decenni, ma già sono in atto tanti importanti cambiamenti. Ecco, serve per affrontare questa innovazione, questa fase rivoluzionaria. È importante che ci sia una nuova generazione di tecnici e di professionisti che comprendano e progettino questi cambiamenti. Menti giovani e aperte, in grado di pensare in modo diverso rispetto al passato. Per queste ragioni il cluster ha espresso formalmente il proprio interesse per la laurea magistrale in Transportation, Engineering and Mobility, e vi aspettiamo tanti giovani laureati che aiuteranno il proprio Paese e, perché no, l'Europa a partecipare da protagonista a questa nuova e importantissima transizione tecnologica.
So let's go now to the master degree in transportation engineering and mobility in terms of its framework, the structure, and how to access to it, and how are the subjects and other things that are practical and that we have well designed in order to facilitate your access and your management of the study plan during your transportation engineering and mobility degree. So there are some prerequisites for the enrollment in this master's degree, and of course the main prerequisite is to have a bachelor degree. This bachelor degree could be in one, let me say, of the engineering classes of bachelors, so civil, industrial, and information and communication technologies. Other cases, other bachelor's degree are considered on an individual basis. Another important prerequisite for enrollment is the proficiency for the English language at least at level B2. It is an international learning environment. We speak in English. There is a stimulating intercultural environment with many international students and who comes from the transportation engineering and mobility master degree is ready, more ready than others for the global markets, and transportation is a global market. Within the master degree, we have a strong connection with the industrial and the economic stakeholders, and all the activities are also synergetic with the National Center for Sustainable Mobility. That is a very important center that has been granted with millions of euros in last few years, and we are fully involved in the activities of the National Center, and we involve also the students. The center is comprehensive of 24 leading economic stakeholders in the transportation sector. We will see some of that in next slides. So this is the framework for the master's degree. First of all, let's note that we have a fully multidisciplinary approach. So this is due because of the broad range of competencies that are requested by the transportation engineering sector. So from a practical point of view, all classes of the first semester of the first year are online. Okay, you can see that here the table that relates to the first year or classes, and the first four of the rows of this table refers to the first semester, and you can see that all activities are online. This allows for a smooth approach to the course also by not ready students. I mean not ready as not logistical ready. You have not yet accommodation, or you have to finish for the bachelor, but you can subscribe to the master degree, or you cannot subscribe to the master degree, but you have few activities for terminating your bachelor, and in the meanwhile you would like to start attending the classes. So note also that the subjects of the first semesters are not propedeutic to the ones of the second. It means that you can enroll later. Let me say you can enroll at the second semester, and this is allowed by the University of Naples, because in general enrollment to the master's degree terminates in the month of March generally, and so you can enroll to the master's degree and start following directly the classes of the second semesters. As you can see, in the first year, there are no elective activities. Everything is mandatory. You have nothing to choose in the first year, and all the choices are concentrated to the second year. This is the table for the second year. You can see that you have 27 credits to be chosen in two short lists, one shorter and the other less shorter. In the first short list, you have to choose one option out of 3, and the second one, 2 options out of 6. And moreover, you have 15 credits that are completely for elective courses that you can choose, as are autonomous choices. And 7 credits are for labs and internship, and 12 credits are for the master degree thesis. 15 credits for the elective activities can be chosen in any way by the students. It's a free choice, but of course this choice is submitted to the assessment and evaluation by the coordinator of the master degree. So we have provided to the students to facilitate their choice of those 15 credits, a list of automatically approved subject. So if one of the students chooses in this list this study plan is automatically accepted. And moreover, for the first of the tables you can see here, which is the list of the course that are supplied by the master degree itself, we also ensures the total compatibility of the timetable for the classes in the whole framework of the study program. For the other two subject in the bottom list, we ensure the automatically admissibility of those choices, but we are not in condition to ensure the full compatibility with all the timetable. Moreover, we have some pre-configured study plans, so in which both the 15 credits and the two choices from the short list, one option on three and two option out of six, all those choices are made by us, and so the students just have to choose a pre-configured study plan. We have three pre-configured study plan. One is smart mobility. It's more, let me say, related to the innovation. Another one is for smart planning. This is related to the transportation planning of services and infrastructure. And another one is related to resilient network. This is the more related to, let me say, the physical components of the transportation, that is infrastructures. If one of those three study plans is chosen, complementing it with 10 extra credits, so more credits, it is possible to attain the diploma supplement in smart infrastructure developer or applied machine learning. It depends on how you add the 10 extra credits. The output, the expected outcome of the learning framework is a multidisciplinary competence for a new generation of engineers that are firmly based in the field of civil transportation engineering, but have a large amount of skills in the fields of automation, data analysis, machine learning, but also information and communication technologies, electric engineering, and power management. This is the mix that the companies we are in touch with ask. You can see here the number of companies with which we have research and innovation contracts, and those are the subjects that are side by side with us in building the learning framework. The learning framework is built in order to ensure that our degree can fit the competencies of those companies.
Hello, my name is Luca, and I was the first student to enroll in and graduate from the master's degree program in transportation engineering and mobility. I chose this path because ever since I was a child, I've been passionate about transportation and felt a need to delve into the technical and operational aspects of this sector. Skills that I was able to acquire at the University of Federico II in Naples. Even before graduating, I found a job as an engineer in one of the largest public transportation companies in Italy. For these reasons and more, I highly recommend all enthusiasts to enroll in TEAM.
Well, I know that the presentation we have had is not exhaustive, so I'll leave you some useful links and references to get in contact with us. We are framed into the Department of Civil Building and Environmental Engineering. You can reach us at this department and in Building 5 in Via Claudio. It's the physical address where we hope that we can meet you in great numbers. And the links you can see here are for any issue you could have or a request for clarification. There are two faculty members that are devoted to tutoring and mentoring, Professor Giovanni Pugliano and Professor Francesco Galante, and Professoressa Francesca Pagliara for everything that is related to internationalization and applying to Erasmus and so on. And I suggest you to give a look and to search for more information at our website. And so I hope that this could be enough to convince you to enroll in transportation engineering and mobility. But now I would like to give you a supplement of information and to leave the floor to faculty members, teachers that are in charge of many of the subject you saw in the lists before. So you can go on with the presentation and have an overview of all the, or at least the great part of the subject and the activities that are into the transportation engineering and mobility program. So thank you for your attention, and I recommend you to stay on and to listen what our faculty members have to say. Thank you.
Welcome to presentation of the Positioning and Location-Based Services course. I am Giovanni Pugliano. This course will take you through the key characteristics of positioning and location-based services, providing you with the knowledge related to the positioning techniques in different scenarios. The lectures will focus on real-time navigation measurements applied to mobile positioning and location-based services. All the geospatial applications in which location, proximity, and connectivity are the organizing principles will be studied. Students must demonstrate that they've learned the fundamental notions regarding measurements and methods for geodetic positioning, concepts and description of satellite positioning and navigation systems, inertial navigation, outdoor and indoor applications, location-based service technologies and issues. By applying the acquired skills, students must be able to collect, process, analyze, and utilize measurements and information for the real-time positioning of moving vehicles.
Hello, good morning. I am Professor Mario Pagano. I want to discuss to you the topics of the course Electric System in Transportation. The course is a mandatory course at the first year, first semester of the Master Science course in Transportation Engineering and Mobility. The course is scheduled in three main sections. In the first section, we focus on the fundamental of the electrical theory, and we recap all the main elements about technological aspect and scheme of power system. In the second part, we analyze the relation between the variable of the motion and energy and power requirement. In the last part of the course, we focus on the technological system for sustainable mobility with special regard to railway system. During this part of the course, we introduce you to simulation by MATLAB and Simulink tools. We have also seminary and laboratory activity on railway system. You can find on the web page the lecture, the note from the lecture, and the reference book. Finally, the exam consists in the first part, which is the solving a numerical exercise, and the second part, which is a discussion with the professor. Good luck to all of you. Bye-bye.
Hi everybody, I'm Stefania Santini and I'm going to teach you systems and control fundamentals. The course will be held at the first year, first semester of your Master Science degree. And the idea is to provide the ability to design controllers. So algorithm able to steer the dynamics of a system in order to follow a commanded behavior. And the idea is to apply it to steer or to solve some transportation problems. So the idea is to steer the dynamics of vehicle, traffic flow, vehicular networks. The course will provide engineering knowledge in the sense we are going to apply mathematical and scientific concept to solve control problems, but also we are going to provide some knowledge of ICT solution in order to implement digital mobility or to address problems related to digital mobility, better to say. So the idea is to provide theory, methodology, and technology for the development of intelligent control algorithm and apply it to ETS problems and CCIM problems, cooperative connected automated mobility problems. We also are going to deal with software, and the idea is to use MATLAB Simulink in order not only to design a controller, but also to verify the achievable performance in a simulation setting. The professional outcomes of the course are be related to the fact that we are going to complement the traditional skills of transportation engineering with some ICT knowledge in order to tackle and solve the challenges arising from the next future digital mobility.
Good morning to everyone. My name is Giancarlo Sperli, and I am the professor of machine learning at the Big Data course. In this course, we will investigating methodologies and models of artificial intelligence in order to address different kind of tasks, for instance, clustering, regression, and classification. In particular, we are focusing on the strategies for training these kind of models according to unsupervised or supervised settings. Furthermore, to improve and to enhance the training process, we will leverage a large amount of data falling under the umbrella term called big data. In particular, we analyzed the concept of big data analytics that aims to infer from this large amount of data knowledge and information that could be used for improving the decision-making process.
Hi everyone, I'm Luigi Pariota, and I am the teacher of the course of Modeling of Transportation Systems. The course has the objective to provide students with all the knowledges that they need to correctly understand, model, and simulate transportation systems. Specifically, within this course, we will provide you with the tools that you need to correctly represent the supply model, correctly estimate the demand, the so-called mobility demand, and to understand in which way these two sub-models, subsystems interact each other. The course is fundamental for those who want to have a career in transportation system engineering.
Hello everyone, I am Giovanni Forte, and together with Stefania Stevenazzi, we are professors of course of digital maps and geological 3D models. The course exploits general knowledge of engineering geology for developing digital applications. It focuses on natural phenomena and the role of geological variables in environmental conditions in engineering design and construction. The course introduces the general concepts of geological data acquisition through in situ and remote sensing survey techniques, and provides the basics for managing and processing geospatial data with geographic information system, also creating 3D geological models. These tools will allow the students to acquire knowledge and software skills for the collection, management, and analysis of data, fundamental for planning and engineering infrastructure, and for identifying hazards and natural resources that interact with them. Thank you.
The Sustainable World Materials course prepares the engineer for knowledge of innovative materials and technologies that are constantly evolving in the field of road paving. Course provides all the tools necessary for identification of a secondary raw materials to replace those traditional used in road paving, provides knowledge of the instrument and methodologies useful for the mechanical utilization, transferred all the congenial tools for design of different sustainable stratigraphic solution studies up to the environmental impact assessment using the CA method. The students who follow the Sustainable Road Materials course will have the opportunity to work in different sectors of the road engineering, such as company production plants for mixtures, or in public administration, covering various roles such as site manager, design director job, or even management roles.
The transport planning and appraisal actually deals with the principles, strategies, methodologies that underlines a sustainable planning of interventions on the transportation system, both physical, organization, and managerial, both on passengers and freight. The real novelty of the course deals with the decision maker, the whole decision making process, where not only the decision maker, private and public, is involved, but also the analysts and designers, but the real novelty is represented by the stakeholders. So public engagement will be an important part, a significant part of the whole decision-making process. What are the employment opportunities from the traditional professionals to the new ones, such as the mobility manager, considering cross profiles, especially with the economics? And what are the job opportunities within the public administrations, public companies, private ones, professional offices, and research centers?
The course on railway and transit services aims to provide students with the knowledge and basic methodological tools necessary to analyze, design, and manage railway and transit services. Indeed, the student will analyze in depth the topic related to the modeling and simulation methodologies for public transport systems, the main aspects of the railway signaling and control system, the organizational and regulatory aspects of the public transport, the design and the optimization of public transport services, the analysis and representation of the considered design scenarios.
This course aims to provide the knowledge of the main constituents of electric propulsion systems. To understand the energy management in transportation, we will see what's inside a hybrid car. The powertrain of electric and hybrid vehicle will be studied. This includes road vehicles, but also railway systems. What happens during braking operation of a bulky train? The braking energy comes back from the wheels and it is redirected to storage systems like battery or supercapacitors. The use of power converters allows to control the energy flow, pursuing environmental sustainability goals in the incoming energy transition.
Hi all, my name is Marcello Cinque. Let me present you the course of real-time systems. So real-time systems are systems used in everyday life to control cyber-physical systems, like, for example, transportation system, vehicles that have dozens of sensors to read the real conditions of the machine and the road, etc., or smart roads. In this course, we are going to provide knowledge about operating system and programming languages to develop real-time systems, particularly in the automotive domain. And also, we're going to provide the skills to design, tune, and develop real-time systems. Thank you for your attention. Goodbye.
Hello, I'm Filomena De Silva, and I'm teaching Resilience of Geotechnical Systems. The main goal of the course is the knowledge of the performance of geotechnical components involved in transportation infrastructures against extreme events that are geophysical events or hydrological events. Why because the failure of geotechnical components may cause the closure of road arches that may produce an effect on the whole network performance. The content of the course are useful for transportation engineers who want to become experts of infrastructure systems and managers involved in decision-making context.
Hello everybody, Chino Bifulco is speaking. I am the lecturer for the course of Transportation System Resilience, elective course for the second year students of the Master in Transportation and Mobility Engineering. It is included in the curriculum of all students who choose the pre-identified program in Smart Planning. It can also be chosen to obtain 6 of the 10 additional credits required by the Smart Infrastructure Developer Diploma Supplement. In this case, the main program chosen should be Resilient Networks. The resilience of transport networks plays a crucial role in the ability of complex transport systems to withstand or adapt to or recover from road disruptions. The causes of road disruption can be of different types and range from natural hazards such as earthquakes or landslides to the effects of climate changes, floods, for example, or other extreme events. It is also worth noting that one of the crucial causes of network failures could be the aging of the infrastructures. As an example, the motorway network of many countries, including Italy, are about to reach the critical age at which some of the key elements, bridges, viaducts, tunnels, should undergo major renovation. This could lead to widespread but controlled failures of the network links subject to maintenance or to disruptive and disastrous failures if maintenance is not carried out. In all cases, the effect of local disruption have to be analyzed at a network level. The resilience of transport networks addresses the need to estimate the propagation effects of network failures in terms of connectivity, serviceability, and accessibility of the entire transport systems, seen as a whole. Indeed, the effects of local faults can be perceived far from the source, or, in other cases, the effect is easily absorbed thanks to network redundancies. The complex and non-linear characteristics of transport networks make it impossible to estimate network effects on a local basis and require the use of analytical tools based on network theory and the application of methods typically of uncertainty analysis. Risk maps have to be transformed into impact maps with appropriate methods and non-linear transformations. Students will learn the basic principle associated to the propagation of disruption effects and to the assessment of the impacts under the different perspectives of topological connectivity, serviceability of the network, which implies taking into account of the demand that loads the network and the equilibrium between transportation demand and supply. Finally, the variation of accessibility can be taken as a measure for impact, and in this case, the effects on the distribution of activities and population in the study area are considered. Resilience issues due to infrastructure aging is increasing momentum worldwide, especially in the most developed countries, and the economic impact of the topic is increasingly relevant. Students with a robust theoretical background and practical abilities related to the analysis of the resilience of transportation system will have increasing work opportunities, mainly in public administration and road operators. Thanks for your attention. Hello everybody, my name is Cino Bifulco and I am the lecturer for the course on smart roads and cooperative driving, elective for second year students of the master degree in transportation engineering and mobility. The subject is also pivotal in the minor program for obtaining the diploma supplement of smart infrastructure developer, as it covers 6 out of the 10 extra credits required for integrating the major program in transportation engineering and mobility. Smart roads play a crucial role in intelligent transportation systems. These roads utilize roadside perception technology, which involves sensors, roadside units, and edge computing devices to collect real-time traffic data. The goal is to enable vehicle-road cooperation and enhance driving safety and efficiency for vehicles with increasing automation levels. To this aim, smart roads integrate advanced network and communication technologies into the road infrastructure. Communication between vehicles and roads play a vital role in creating safer and more efficient traffic conditions. It contributes to prevent accidents by providing real-time warnings about nearby vehicles, obstacles, or pedestrians in urban areas. Enable faster emergency response by transmitting critical information and clearing the way for emergency vehicles, optimizes traffic flow, increase road throughput, and reduce congestion, addressing greening goals and enhancing overall road safety. Students will learn the basic principles and technologies adopted for smart roads, the smart sensing technology, and their basic functioning and performing in the characterization of traffic variables, the cooperative intelligent transportation services that can be developed adopting smart road communications. The students will be provided with the theoretical and operative tools for the estimation of the effect of smart road transformation tools, allowing test before invest analysis and assessing the benefit of implementation. The global market for intelligent transportation systems has been steadily growing, driven by technological advancements and the need for efficient transportation solutions. Depending from different sources of estimates, the global market is estimated from 28 to 52 billions of US dollars, with an expected growth rate for the investment in the sector from 8% to 11% per year in the next 10 years. The work market for transportation engineers specializing in smart road is evolving rapidly due to the increasing worldwide adoption of intelligent transportation systems and the development of smart cities and smart road networks. Working opportunities are open in the field of design, implementation, and ongoing maintenance of smart roads, and workplaces are mainly in public administration, road operators, innovative road construction enterprises, and technological suppliers and system integrators. Thanks for your attention.
Welcome to the online presentation of the Master Degree in Structural and Geotechnical Engineering at University of Naples, Federico II. The master course in Structural and Geotechnical Engineering is within the framework of the Civil Engineering. It is offered at the Department of Structures for Engineering and Architecture, both in Italian and English language. However, today we will focus on the master program in English language, which is mainly devoted to international students. I am Emilio Nigro, one of the teachers of the master course, and from some years I am also the coordinator of the master degree. The master degree in structural and geotechnical engineering is within the field of the civil engineering. Probably you know a famous sentence by the American Society of Civil Engineers, which says civil engineers build the quality of life. So the structural and geotechnical engineers are characterized by a strong basic knowledge and skills in the field of civil engineering, but in addition by a deeper culture, knowledge and skills in specific application field of the civil engineering, as for example in the design of new structures and infrastructures for building and industrial building, in the assessment, recovery and retrofit of existing buildings, in the design of geotechnical works. I have a question for you. Why should you choose the master degree in structural and geotechnical engineering, the acronym is STREGA, at the University of Naples Federico II? We already said that the master degree aims to prepare a professional figure who combines a basic training and knowledge in the main field of civil engineering with a particular specialization in the design, execution, management of structural and geotechnical works. There is no other master degree in Italy with this specific focus. You have the possibility of a study course all in English language, and this is specifically devoted to international students. But the educational offer is very wide, and this leads to the flexibility of the training course with over 45 courses, teaching courses, considering both that offered in Italian and in English language. From the current academic year, we have also the possibility of a double degree with the University of Lisboa. This means that the student can obtain a double degree, the master degree in structural and geotechnical engineering at the University of Naples and the master degree in civil engineering at the University of Lisbon. The students will have also the possibility to join the interdisciplinary training project named Minor Transition Technologies with a specific qualification as developer in smart infrastructures. We have also an extensive choice of internship, in particular extramenia internship among public and private institutions, professional firms, engineering companies and construction companies. The numerous international agreements allow the student for studies and training abroad, Erasmus Learning, Erasmus Placement. From the next academic years, 2024-2025, it will be activated also the Italian Erasmus with the possibility of studies, part of studies in other Italian university. Finally, The students will enjoy the possibility of very interesting activities, experimental activities in the laboratories which are present at the Department of Structures for Engineering and Architecture and the Department of Civil Engineering. In this slide, you can see some picture related to the applicative fields of the structural and geotechnical engineering. The design of new structures for civil and industrial buildings, the design of geotechnical works, for example, a tunnel, the design of infrastructures as bridges or special structures as dams, as you can see in this picture. The problems of assessment, recovery, retrofit, and requalification of existing building, both ordinary existing buildings and also buildings for of the cultural heritage. The soil protection is also an application field of the structural and geotechnical engineering. Some other interesting examples of application of the application field of structural and geotechnical engineering. I would like to start from this picture, which is related to the suspension bridge designed by Luigi Giura, which was the first graduated engineering at the School of Application of Bridges and Roads, founded by Gioacchino Murat in Naples in 1811 on the model of the École Nationale des Ponts et Chaussées in Parigi. This is a famous reinforced concrete hangar designed by Pierluigi Nervi, another famous structural engineer, a cable-stayed bridge, a tall building with steel structure, and in this picture you can see a dam with a light aluminum structure. Finally, a tunnel with precast concrete segments. Picture other examples of the application field of structural and geotechnical engineering as this famous tall building characterized by big dimensions of the structural members, in this case steel concrete composite members. In this other case we have long beams in steel. Our students will learn also the capacity to model, to solve complex model by means of a finite element model, both in linear and non-linear field. Another important field of application is the design of the protection works against the natural risks, as for example seismic and hydrogeological risks. In this picture you can see a seismic isolation system in order to mitigate the seismic risk. In this other picture you can see protection works of the soil for the mitigation of the hydrogeological risk. The application field of the structure and the geotechnical engineering is not only for the design of new structures and infrastructure, but also for the assessment and the retrofit of existing buildings, which could be ordinary existing buildings and also the problems of conservation, restoration, and also retrofit of buildings of the cultural heritage. The students will be able to use both traditional technique, retrofit techniques, but also in innovative retrofit techniques, as for example the composite ones. But not least, our student will enjoy, for example, during the preparation of the master thesis, the possibility to have a very interesting experience in our test laboratories. For example, the structural laboratory and the geotechnical laboratory. In particular, in the structure laboratory, we have two shaking tables for dynamic tests, some hydraulic machines for test in tension and in compression, numerous static and dynamic tests are performed on specimen and also on real scale structure, real scale part of structures. Recently, we are also going to equip a fire test laboratory. What are the career opportunities for the graduate in structural and geotechnical engineering? First of all, the professional activity as freelance and the possibility of employment in professional firms and engineering companies. Also in public authorities and administration, as for example state railways, motorway company, Ministry of Infrastructure and Sustainable Mobility, Ministry of Interior, civil protection, and so on. In general, private companies which operates in the field of construction and civil structure and infrastructure. And finally, also the possibility of employment in research centers, university, the National Council of Research, European and international research centers. Well, now we move to the description of the teaching organization. The master degree in structural and geotechnical engineering, as all the master degree in Italy, is articulated in 2 academic years for a total of 120 university training credits. ECTS is the acronym, European Credit Transfer System. The educational activity is organized in 2 years and in 2 semesters for each academic year. We have, first of all, 99 ECTS offered by 11 teaching courses, and in addition 9 ECTS for the internship. The internship could be held intramenia or extramenia, which means inside the university or outside the university, and finally 12 ECTS for the final exam, which involves the preparation of the master thesis. The teaching activity include theoretical lesson and exercise related to the theoretical topics, and we adopt the system of frontal teaching. In addition, we have thematic seminars on specific design problem, on specific topics. We organize guided technical visit related to works already realized on under constructions. The teachers during their courses organize also exercise in laboratory, and in addition the students will enjoy the possibility of develop part of the thesis in experimental activities in laboratory. We have also designed laboratories, activity of tutoring for the students, as said before, internship, traineeship intramenia or extramenia, and finally also period abroad the university, thanks to the numerous international exchange programs as the Erasmus Plus program and also several international agreements, not Erasmus, and as said before, also the double degree with the University of Lisboa. Some further information on the study plan. As said before, we have in total 11 courses distributed on 4 semesters during the 2 academic years. Some courses are mandatory. Other courses are of your choice between a restricted and suggested number of courses. For example, one choice between 2 courses. In other case, you have a choice between a larger number of courses. Therefore, concerning the first semester, we have the teaching course devoted to earthquake engineering and structural control, which is mandatory, and the teaching course limit analysis of structure, which is mandatory too. In addition, if necessary, which means on the basis of an entry test performed by the students at the beginning of the educational path, we have the possibility to include additional training requirements in order to recover some basic knowledge in geotechnics, continuum mechanics, and structural engineering. In the second semester, we have the course Static and Seismic Foundation Design, which is mandatory, and after we have a possible choice between 2 courses in the field of reinforced concrete structure and another choice between 2 courses in the field of the steel constructions. Finally, there is also the possibility to have an optional teaching course devoted to advanced and applied engineering mathematics. In the first semester of the second year, you have a choice from 2 to 4 courses in a group of 5 courses, which are FEM in nonlinear structural analysis, mechanics of composite and advanced materials, assessment and retrofit of structures, theory and design of bridges, and structural reliability. In the second semester, there is a choice from 2 to 3 courses in a group of 5 courses: Advanced Metallic Structures, Advanced Applied Engineering Mathematics, Innovative Building Materials, Geotechnical Modeling, and Tunnels and Underground Structure. I would like to underline that the flexibility of the study plan depends on your choices in the several semesters. In other words, the total of the teaching courses is 11, but you can distribute these teaching courses between the 4 semesters, obviously taking into account the mandatory course. In addition, I would like to underline that some courses may be located at the first or second year according to the whole study plan that has to be approved by the Master Degree Commission for the study plans. The educational path is completed by the internship training activity and by the preparation of the master thesis at the end of the educational path. Just described the educational path, especially devoted to international students, which foresee courses all in English language. But we have, as I said before, a general study plan with the courses both in Italian and in English. The framework is the same described before, which means in total 11 teaching courses, and in this case, 6 of these courses are mandatory. In particular, we have the possible choice between 2 or more restricted courses. In some case, there is an alternative between the same teaching course offered in Italian or in English. The remaining 5 courses may be chosen by the students among a very wide list of teaching courses, both in Italian and in English. In addition, we have the internship, intramenia or extramenia, the linguistic knowledge, English language, and the final exam with the dissertation thesis. In this slide, you can see the main offered teaching courses, both in Italian and in English, that you can choose for your study plan. Please refer to the booklet, the student's guide on the website of the master degree for more information on the contents of the several courses. Therefore, the possibility of choosing from a wide list of courses allows students to direct the thematic path of their studies. And this leads to a very high flexibility in the educational path, which may be devoted, for example, to the design and execution of new structures for building and infrastructures, to the assessment, recovery, restoration, retrofit of existing structures and infrastructures, or to design of geotechnical works for building infrastructures and also to soil protection. Now we move to illustrate some further opportunities for our students. The first one is an educational innovation which is active since academic year 2021-2022, which consists in the so-called minor in transition technologies devoted to smart infrastructure. Really, infrastructure are a strategic asset for the economic development and civil life of society, and today it is necessary to provide their physical and functional requalification. So, the minor in smart infrastructure developer is a complementary educational path which combines the basic preparation of our students in the subjects, topics characterizing the Strega Master Degree course with the transversal skills from other engineering disciplines and also digital skills. The minor path provides at the end a qualification as an expert in smart infrastructure. The minor complementary study course in Smart Infrastructure Developer is distinct from the main study courses. The student can attend the minor in partial overlap with the main master degree studies. Synthetically, we can say that the minor is obtained by acquiring 30 credits ECTS of educational activities, and the qualification in Smart Infrastructure Developer is attested by a university certification as diploma supplement and open badge. Concerning the 30 specific credits devoted to the minor, we have to underline that 18-20 CTS are recognized as curricular credits within the Strega Master Degree educational path, whereas 10 12 ECTS are recognized as additional credits, extracurricular credits. Therefore, the minor study course has a total of 130-132 ECTS instead of the normal 120 ECTS. The interested students have to prepare a study plan which contains some specific types of training activities chosen within the some tables of suggested activities, table A, table B, table C, and table D. Table A is a table of educational activities specifically developed for the smart infrastructure minor. Table B contains educational activities with transversal technical scientific training activities derived from the disciplinary training already offered by the degree courses. Table C is devoted to training activities for the promotion of the digital skill, and finally Table D are training activities for the promotion of transversal skills, and the application of Table D activities may be developed through specific seminars or project work acceptable as additional knowledge. Further information could be derived by the website. Another interesting opportunity for our students is the double degree, which is active from the current academic year with University of Lisboa. The interested students have the opportunity to obtain a double university master degree, the master degree in structural and geotechnical engineering at University of Naples Federico II, and the master degree in civil engineering at University of Lisboa, remaining in a total 2 years academic educational path. The study plan for the double degree includes a first year at University of Naples Federico II with 60 ECTS, with mandatory and elective courses, and the second year at University of Lisboa with a total of 60 ECTS, which are composed by mandatory and elective courses and the preparation of the master dissertation, of the master thesis. The master thesis for the double degree is carried out under the supervision of faculty member of the host institution, which means in this case the University of Lisboa, and a faculty member of the home institution, which means the teachers of the Strega master degree. The master thesis is developed normally at the host institution and is presented also in the host institution. The jury of the thesis should be composed by faculty members from both institutions. In this picture, you can see a possible study plan for the double degree, which include the first year at University of Naples with some mandatory and elective courses, and the second year at the University of Lisboa with some mandatory or elective courses and the preparation of the master thesis dissertation discussed, as said before, at the host institution, but under the supervision of faculty members by both the institutions. Finally, the double degree educational path is a very interesting opportunity for our students. Scholarships are also available for the students who join the double degree program. The internship is mandatory in the study plan of the master degree in structural and geotechnical engineering. The students may choose between intramedia internship, for example, in test laboratory of the departments of Federico II University, or for an extramedia internship. At the moment, over 80% of students chose the extramedia internship in engineering companies operating in the design and the construction of civil works, in public authorities and administration, in private companies, always in the field of construction and the civil infrastructure, or in research centers. The students may use the platform job service in the website of the Polytechnic and Science School of Federico II University, which that is a platform which promotes the communication between companies and the students, also for the internship opportunities. In this picture, you can see some students which opted for the extramedia internship, the protagonist of this experience. And I would like also to underline that the extramedia internship constitutes also a first work experience for the student and can, in some cases, lead to a direct hiring. Another interesting international opportunity is the Erasmus program, which is an opportunity for promote cultural, social integration and exchange between students, for developing and strengthening the skills of the students, and also increasing employment opportunities for the students. The Erasmus program may include teaching activities, internship activities, and also part of the dissertation thesis in another university. Generally, the period for the study abroad within an Erasmus learning agreement is between 3 to 6 months, depending on the type of training activity for a SIN, but maybe also more than 6 months. It is necessary to have an internship institutional agreement with the institute to which the students belong. In this picture, you can see an overview of the many existing agreements with other European universities. From the academic year 2024-2025, also the so-called Italian Erasmus will be activated. This means that the students have the possibility to carry out part of the study course, at least 12 ECTS, in a study course at another Italian university. The criteria are similar to the European Erasmus, and the planned training activities can be curricular teaching courses, internships, and also part of the master thesis. At the moment, the agreements planned are with the University of Padua, Pavia, Pisa, Basilicata, and Cagliari, Catania, and Polytechnic of Bari. The Italian Erasmus experience at another university will start from the second semester of the academic year 2024-2025. So these are the main contents and characteristics of the master degree program in structural and geotechnical engineering at University of Naples, Federico II. For further information and more detailed information on the master degree program, please refer to the website of the master degree www.strega.unina.it. Also, the online students guide at UNINA website could be useful for further information. And finally, the contact persons. Myself, Emilio Nigro, coordinator of the master degree in structural and geotechnical engineering, and above all, the educational office of the master degree, Dr. Valeria Peluso. Email is didattica.dist@unina.it. Other contact person of our team are Professor Giampiero Lignola, Delegate for Guidance and Tutoring, Professor Antonio Bilotta, Delegate for the Internship Opportunities, Professor Beatrice Faggiano, Delegate for the Double Degree Opportunities, and for the international students, please refer to Professor Gaetano Della Corte, who is the Delegate for Internationalization of the Department and of the Master Degree, and finally Professor Maria Polese, Delegate for Erasmus Opportunities. Well, I thank you very much for your kind attention, and I hope to see you in the future in Naples for the master degree in structure and geotechnical engineering. Thank you again, and see you in Naples.